Every 14 seconds, somewhere in the world, a woman is diagnosed with breast cancer. But why does this disease develop in the first place? Today, we're diving deep into the science behind breast cancer, understanding not just what happens, but why it happens, and most importantly, what factors influence its development. Hi everyone, and welcome back to channel. In today's video, we're tackling one of the most important health topics affecting women worldwide. By the end of this video, you'll understand the biological mechanisms behind breast cancer, the key risk factors, and what the latest research tells us about prevention. So let's get started. Section 1. The basics, understanding normal breast tissue. Before we can understand what goes wrong in breast cancer, we need to understand what normal looks like. The breast is made up of three main components. First, we have lobules. These are the milk-producing glands. Think of them as tiny factories that can produce milk when needed. Second, we have ducts. These are the tubes that carry milk from the lobules to the nipple. They're like the highway system of the breast. And third, we have connective tissue. This is the fibrous and fatty tissue that surrounds and holds everything in place. What is cancer? Now, cancer isn't just one disease. It's actually a group of diseases characterized by abnormal cell growth. In healthy tissue, cells grow, divide, and die in a controlled manner. Your body has sophisticated systems that regulate this process. But sometimes, these control systems fail. When cells begin to grow uncontrollably and don't die when they should, they can form a mass called a tumor. Not all tumors are cancerous. Benign tumors stay in one place and don't spread. But malignant tumors, which are cancerous, can invade nearby tissues and spread to other parts of the body through a process called metastasis. Section 2. How breast cancer develops, the cellular level story. Breast cancer development is a multi-step process that usually takes years or even decades. It starts at the cellular level with DNA damage. Every day, our cell's DNA faces thousands of attacks from various sources: UV radiation, chemicals, even normal metabolic processes. Usually, our cells can repair this damage, or, if the damage is too severe, the cell will self-destruct through a process called apoptosis. But sometimes, damage occurs in critical genes, particularly those that control cell growth and division. We call these oncogenes when they promote growth, and tumor suppressor genes when they normally prevent uncontrolled growth. Think of oncogenes as the accelerator in a car and tumor suppressor genes as the brakes. Cancer can develop when the accelerator gets stuck or the brakes fail. The progression timeline. The development typically follows this pattern. Stage 1. Normal cells experience DNA damage. This might happen in a single cell among the billions in breast tissue. Stage 2. If this damage affects growth-controlling genes and isn't repaired, the cell may begin to divide more than it should. We call this hyperplasia. Basically, too many normal-looking cells. Stage 3. With additional mutations, cells start to look abnormal. This is called atypical hyperplasia. The cells aren't cancerous yet, but they're heading in that direction. Stage 4. More mutations accumulate, and we get carcinoma in situ. Cancer cells that haven't yet invaded surrounding tissue. They are contained within the ducts or lobules. Stage 5. With further changes, cancer cells gain the ability to invade surrounding tissue. This is invasive breast cancer, and these cells can potentially spread to other parts of the body. Types of breast cancer. Most breast cancers, about 80%, start in the ducts. We call these ductal carcinomas. About 10% start in the lobules. These are lobular carcinomas. The remaining cases include rarer types like inflammatory breast cancer and Paget's disease of the nipple. Section 3. Hormonal influences, the estrogen connection. Here's where things get particularly relevant to why women are so much more affected than men. Estrogen, while essential for many bodily functions, plays a complex role in breast cancer development. Estrogen doesn't directly cause DNA damage like radiation might. Instead, it acts as a growth signal for many breast cells. If a cell has already acquired some cancer-promoting mutations, estrogen can fuel its growth. Think of it like pouring gasoline on a small fire. Estrogen can accelerate the growth of abnormal cells. This is why factors that increase lifetime estrogen exposure tend to increase breast cancer risk. These include starting menstruation at a younger age, entering menopause at a later age, never having children or having them later in life, not breastfeeding, taking certain hormone replacement therapies, hormone receptor status. Not all breast cancers are influenced by hormones. About 70% of breast cancers are hormone receptor positive, meaning they have receptors for estrogen and/or progesterone on their surface. These cancers can be fueled by hormones. The remaining 30% are hormone receptor negative and grow independently of hormonal signals. There's also HER2, another type of receptor. About 15 to 20% of breast cancers overproduce this protein, making them grow more aggressively. Understanding these receptor statuses is crucial for treatment, as different types respond to different therapies. Section 4. Genetic factors. Inherited risk. While most breast cancers aren't inherited, about 5 to 10% are linked to inherited genetic mutations. The most well-known are BRCA1 and BRCA2 mutations. These genes normally help repair DNA damage, but when they're mutated, that repair system doesn't work properly. Women with BRCA1 mutations have about a 72% lifetime risk of developing breast cancer by age 80, compared to about 13% in the general population. For BRCA2, it's about 69%. These mutations also increase the risk of ovarian cancer and, in men, prostate and breast cancer. Other genetic mutations that increase risk include TP53, Li-Fraumeni syndrome, PTEN, Cowden syndrome, CDH1, hereditary diffuse gastric cancer syndrome, STK11, Peutz-Jeghers syndrome. Family history without known mutations. Even without identified mutations, having a family history increases risk. Having one first-degree relative with breast cancer approximately doubles a woman's risk. Having two first-degree relatives increases risk about threefold. This suggests there are likely other genetic factors we haven't discovered yet, or that shared environmental factors play a role. Section 5. Lifestyle and environmental factors, modifiable risk factors. Now let's talk about factors we can actually control. While we can't change our genetics or age, numerous lifestyle factors influence breast cancer risk. Alcohol consumption. Even moderate drinking increases risk. Alcohol can increase estrogen levels and damage DNA directly. Risk increases by about 7 to 10% for each alcoholic drink consumed per day on average. Physical activity. Regular exercise reduces risk by about 10 to 20%. Exercise helps maintain healthy weight, reduces inflammation, and may lower estrogen levels. Weight. Being overweight or obese after menopause increases risk. Fat tissue produces estrogen, and excess weight is associated with higher insulin levels, which may promote cancer growth. Diet. While no single food prevents cancer, dietary patterns matter. Mediterranean-style diets rich in vegetables, fruits, whole grains, and healthy fats are associated with lower risk. Environmental exposures. Certain environmental factors also play a role. Radiation. Exposure to ionizing radiation, especially during childhood or adolescence when breasts are developing, increases risk. This includes medical radiation from repeated chest X-rays or radiation therapy. Chemical exposures. Some chemicals, called endocrine disruptors, may influence risk. These include certain pesticides, plastics, like BPA, and chemicals in personal care products. Research is ongoing, but minimizing exposure when possible is reasonable. Shift work. Some studies suggest that working night shifts may slightly increase risk, possibly due to disruption of circadian rhythms and melatonin production. Section 6. Age and reproductive factors. Why age matters. Age is the biggest risk factor after being female. The median age at diagnosis is 62. Why does risk increase with age? Several reasons. First, we accumulate DNA damage over time. Second, our DNA repair mechanisms become less efficient as we age. Third, we've had more years of exposure to risk factors. And fourth, the hormonal changes of menopause alter breast tissue in ways that may promote cancer development. Reproductive history. Your reproductive history significantly influences risk. Pregnancy, having children, especially before age 30, reduces risk. Pregnancy causes breast cells to mature, making them less susceptible to cancer. However, risk temporarily increases right after pregnancy due to hormonal changes. Breastfeeding. Longer duration of breastfeeding is associated with lower risk. This may be due to reduced lifetime number of menstrual cycles and hormonal changes during lactation. Menstrual history. More lifetime menstrual cycles means more estrogen exposure. This is why early menstruation, late menopause, and never having children increase risk. Section 7. Prevention and early detection. What you can do. While we can't prevent all breast cancers, we can reduce risk. Maintain a healthy weight, especially after menopause. Exercise regularly. Aim for at least 150 minutes of moderate activity weekly. Limit alcohol consumption. Don't smoke. Breastfeed if possible. Carefully consider hormone therapy risks with your doctor. Know your family history and discuss genetic testing if appropriate. Screening and early detection. Early detection dramatically improves outcomes. Follow screening guidelines. Monthly breast self-exams to know what's normal for you. Clinical breast exams as recommended by your healthcare provider. Mammograms according to guidelines, typically starting at 40 to 45, or earlier with high risk. Additional screening like MRI for high-risk individuals. Remember, most breast changes aren't cancer, but knowing you're normal and reporting changes promptly is crucial. Understanding why breast cancer develops empowers us to make informed decisions about our health. While we can't control all risk factors, knowledge about prevention and early detection saves lives. Remember, if you have concerns about your breast cancer risk, talk to your healthcare provider about personalized screening and prevention strategies. If you found this video helpful, please give it a thumbs up and subscribe for more health and science content. Share this with someone who might benefit from this information. Do you have questions about breast cancer or topics you'd like me to cover? Leave them in the comments below. Thank you for watching, and remember, knowledge is power when it comes to your health. I'll see you in the next video.